Good morning. So let me say from the outset, I'm pleased that Realization extended an invitation to me to speak here with you today and really share what we believe is a good news story. And I'd like to thank them also for their hospitality through this conference. Over the next couple of slides, I'll try to frame your understanding of our program and some of the complexities of our simulation. Okay, so as it was stated at the outset, we're training future naval flight officers. Most of these students will go on to become F-18 backseaters, weapon systems officers. And so our simulation really spans a broad spectrum of training. We have the classroom task simulations, which include the primary, intermediate, and advanced curriculum. And we also have the instrument flight trainer, which is training the students on basic flight, basic cockpit switchology, and then our operational flight trainer, which is a bit more complex, and I'll touch on that in the next couple of slides. We have approximately 25 engineers and support personnel working on the program, comprised of software, systems, electrical, mechanical, test, logistics, the whole gamut. And we've had about 4 years worth of progress at the point where we implemented CCPM and Concerto. And we have about 2.5 years remaining on our contract. The first device, of course, is our instrument flight trainer. It's a full physical and functional replication of the aft cruise station of the T-45 aircraft, the T-45C. It incorporates primary and secondary control loading systems for the such things as the stick and the throttle, landing gear handles, all of which are intended to simulate in full fidelity the flight control forces on these various controls. The motion system is basically a pneumatic and electromechanical motion system providing onset and haptic cues for the student. And then, of course, as you can see on the back there behind the cockpit is where the instructors sit and control the simulation and provide real-time interaction and feedback back to the student. The next device is the operational flight trainer. And this is our more complex simulation where it capitalizes on the basic IFT, and it adds, in addition, it provides a 220 or 210 degree horizontal by 90 degree vertical field of view display, which provides a fully immersive environment for the student to train. In this environment, or in this trainer, we're training the student on both air and surface threat interaction, formation and tactical fundamentals, and basically he's operating in a high fidelity environment. So from the program background perspective, there's much I can say here, but I'll just say it, bottom line is that we were many months behind schedule, and there were many challenges really that were conspiring to make the program substantially late. We were creating a very unhappy customer, and more to the point, we were affecting the student throughput of our future warfighters. And so from a company perspective, we were creating significant cost overruns on a firm fixed price contract. So when a program gets late to need, of course the customer gets unhappy. And my management wasn't any too pleased as well. So by employing CCPM and Lean Plus and Concerto, we were able to substantially improve our schedule and our performance. And by extension, we were able to improve on our savings, or cost savings. So what we did was we asked for some help. We needed to do something different than what we had done previously. And so our target was to try to reduce the program schedule and try to get as much back on track as we possibly could for the sake of our customer and for our own cost. So we targeted essentially to try and find a way to rein in our schedule. We also needed to demonstrate that schedule could be improved without compromising on our quality in any way. So operationally, in terms of our challenges, I could spend a great deal of time up here today speaking about the various myriad of operational and execution challenges that we faced and the details associated with each one of those. But I'll suffice to say that we needed to really adopt a completely different way of performing, a different approach, and change from our typical operating paradigm. So as you look at, you think in the context of a program, in real life, we only see waiting. We see a lot of waiting, too many interruptions in our typical business day, and too much waiting. Equally undesirable is unsynchronized task execution, which previously had resulted on our program in costly rework. So obviously, interruptions and waiting has a big impact on quality. And multitasking, which everyone seemed to think was a good thing, actually was leading to lost focus and indeed was leading to diminished first-time quality for our customer. So although there is uncertainty in natural loss, a big chunk of losses are due to how we manage and indeed are avoidable. By minimizing interruptions and synchronizing tasks and actively managing the work, the focus correctly shifts to the system constraint. End result is the schedule is reduced, costs are reduced, and quality is improved. In order to implement CCPM and Concerto and be successful as a core team, we created a core team, and then we went about trying to educate that core team on the fundamentals of critical chain and on the Concerto tool. It was important for us to try to get team buy-in, create a new low whip plan, develop a new operating rhythm, which was completely different from our existing paradigm. And roles and expectations were set, and then we began to execute the plan. So over the course of about a 14-month period, our design and development phase was completed 45 days ahead of schedule. The prior history had demonstrated that meeting the baseline was going to be a real challenge using our traditional execution plan. So hardware-software integration phase was the next phase to follow after our design development phase, and during that phase we finished 32 days ahead of schedule. Understanding the complexity of a simulation of this nature, those kind of savings are monumental on our program. We had unprecedented quality for a training device of this complexity. Our preliminary design review was completed without a single request for action, which is almost unheard of. Our critical design review was completed with only 4 RFAs, which is, again, incredible. I think part of the credit really here goes to substantial customer involvement throughout every step of our design process. And I'll discuss that further here in some subsequent slides. So in the following slides, I'm going to attempt to illustrate a little bit of what we did relative to each one of these rules: pipelining, buffering, and buffer management. So this was our typical approach to starting design. And imagine, if you will, I kind of get this mental image of the Boston Marathon, and I never really thought of it. Having worked for Boeing for almost 30 years now, we all tend to get set in our ways a little bit, and we do what we've always done. And so when we started this program, we did what we've always done. We had this waiting for the gun to sound, and everybody is off and running. Hardware engineers, electrical engineers, software, mechanical. Everybody's working their independent tasks. There's a network schedule out there, but everybody is off and running with no consideration of how many work streams we actually had in play at any one time. So in this scenario, it was challenging at best to identify the top priorities and focus and synchronize across the various teams that are in motion. Probably impossible is a better way to characterize that. And there's, our standard mode of operation is lots of pressure to start all of these tasks and get them in motion. And with no consideration of full kit and pressure sometimes to deliver before some of the tasks were actually fully complete. So it was a very challenging environment for any leadership, and with few software and systems engineering experts on the program, it becomes even more challenging. Historically, managing this way produced significant schedule delays, cost overruns, and poor quality. And we were seeing that directly on my program. What we did as a function of our working with realization was to take a different perspective on the work that we had to achieve for the OFT device. We prioritized and batched functionality into what we called 4 design threads. And we were careful in our batching process to ensure that the tasks that we put into each thread were tasks that related to each other and were tasks that could be effectively started and finished. And we had, with a staggered thread approach, we ensured that we had no more than 2 threads in flow at any one given time. So we would have only one preliminary and then detailed design thread in WIP at any given time. And before we would, as soon as we would get done with the preliminary and detailed design in each of those threads, we would progress into code and unit tests. So those were really the software guys that were doing the development during code and unit test. And then the designers, some of the designers would then move on to the preliminary and detailed design of the subsequent thread. At the end of each one of these preliminary and detailed design threads, we also did something that we hadn't typically done before either, and that was we had a review with the customer at the end of each one before moving into code and unit test. This really served to make the customer feel like they were integral in our process, and that we were providing exactly what our customer was expecting. So the bottom line in this is that before we would progress to the next step, we were obtaining and achieving consensus within the team and with the customer as well. So the challenge really is to define an appropriately challenging and aggressive buffer, but not so aggressive of a buffer that it appears unachievable. And this was for me was a fine line as well. In our company, when we execute on a contract, we automatically carve out a piece of that budget, and we call it management reserve to cover any risks that have been identified against the execution. So we already took out typically 10% of our budget to account for future risks and be able to work those. So all of our team really knows that they've already been decremented 10% out of the gate, and now we come along and we're asking them to put another big chunk of hours and budget into buffer. And so it really is getting your head wrapped around the fact that it is a buffer and there's some expectation that you're going to use it, but the challenge is to not use it all. And so you don't want to get your team discouraged right out of the gate by making it too aggressive, but you don't want to make it so easy that there's not a challenge there for them to try and achieve greater things than they've probably been able to do in the past. So in terms of meetings, from a lean standpoint, we had already implemented, I would say, a process, if you will, internal, to eliminate as many meetings as we possibly could. We had a tendency in the past to have one meeting after another. People would get up from their desk, go to a conference room, assemble, wait for somebody to bring up the slides on the screen, have your meeting, and then disperse back to their desk and continue working. That's very inefficient, and we really have done a good job of eliminating all meetings, almost all meetings. Most meetings that we have are done via WebEx and Telecon. So when you look at this slide, we actually combined our weekly, our ops and our look-ahead meetings into a single meeting for 1 hour on Mondays, and usually that's 1 hour max. In recent weeks and months, we've done it in a much shorter period of time as the team has become more adept at understanding the process. Our daily tag-ups are also done via Telecon and WebEx. So each engineer or each task manager or each manager that's involved with the process can sit at their desk and participate in the telecon and are immediately back productive as soon as the teleconference is over. But we find these teleconferences and WebExes for these meetings are essential. And it not only provides daily perspective on your critical tasks and critical chain, but it also serves the dual purpose of applying peer pressure and accountability to each person on the team. So in a typical government contract, we had both requirements for EVM and weekly EVM statusing and quarterly EVM statusing all the way up to the higher levels within our organization. And so we had to manage both an aggressive CCPM plan and a high confidence EVM baseline as well. With regard to shared resources, we were able to establish clear priorities for our resources as well. On the next bullet, I can't overemphasize the necessity of customer buy-in. This is critically important, and making them feel like they're an integral part of the process and that they have clear visibility into everything that's going on. This is probably one of the more challenging aspects on a government contract, but it supports faster decisions and reviews, excuse me, and testing with fluid schedules. And for those of you who are accustomed to working on government contracts, you know that we have contract deliverables which are tied to certain milestones or certain events in the schedule and certain data item description requirements as well. So you have to have customer buy-in to tailor those requirements, or at least to get accommodation for the fact that you're going to try to move faster. And Boeing is a fairly large bureaucracy, as is the U.S. government. And so trying to get both of those ships moving in the same direction at the same time can be a little bit challenging. But I can say with some pride that we've actually been able to achieve that. And some of that credit, of course, goes to our Navy customer, who's been willing to work with us and try to adapt as well. You're really changing the culture as well from more of a culture of performance to plan, and instead of duration remaining and buffer management versus percent complete and CPI. And then last but not least, obviously, as it relates to the challenges, as I mentioned earlier, probably the biggest obstacle to this implementation was me, because I was used to doing things a certain way. But my team was equally as challenged in this regard, because something new is always introduces a certain amount of uncertainty, and it takes a while to get the team to come around and buy in. But eventually the team did, because we were able to establish early on that and see readily that there were benefits associated with implementing. So we had realization came and were fantastic and working with us. It took us about a month for the core team to be established and create a new low WIP plan. Our focus shifted immediately to smaller batches of functionality, substantially reducing WIP, and as a result, both communication within the team and with the customer improved almost immediately, as did the quality of the product that we were building. So it's critically important that everyone from top to bottom on the organization understands and embraces CCPM. You cannot do this in a silo. And my suggestion is we ended up having to implement when we were in a situation where our program was starting to hurt. So the earlier you can employ CCPM on your project, the better. This will minimize the changes midway through the program and really provide your program with the highest chance for success. And this last bullet on here is really important, because a team will quickly internalize the benefits of CCPM through early successes. And this will engender their support as you move on and as you increase your buffer withhold. So at the program level, our daily operating rhythm with Concerto helps us manage these disciplines. The task lists are critically important in this process as well, both in terms of staying focused and establishing top priorities, limiting WIP, and reducing multitasking. But the preparation and execution checklists are essential to making sure that that the task is ready to start when it's truly ready to start, and that you've identified all of the criteria that will be able to justify that you've actually completed the task. So everyone's looking at the same information, and it helps us to stay very focused and subordinate to what is most important each day. The trend charts, of course, keep us focused on the aggressive target date and quickly identifies the impact of buffer and whether we need to take additional action to try to recover. That lack of clear priorities, a high WIP, and multitasking can still occur even after you've started this, because bad habits are easy to fall back into. Thus, it's important that the team leads are modeling and exhibiting and rewarding the kinds of behaviors that you're trying to implement. So from a lessons learned perspective, we were able to identify unknown risks and include additional unplanned scope, allowed the team to work through several program issues, and allowed the team to gain buy-in to the strategy as they helped develop the solution. So I'd like to say in conclusion, Albert Einstein's definition of insanity is doing the same thing over and over again and expecting a different result. Or as stated differently by Anthony Robbins, who's a renowned motivational speaker, if you always do what you've always done, you will always get what you've always gotten. I can tell you that we've been able to turn around a program that was in trouble. We've restored confidence with our Navy customer. We've ensured that the student throughput will be maintained. And I started out as a skeptic, and now I'm a huge advocate. So with that, I guess I'll turn it over to questions.